So I'm going to be talking to you about Glass, specifically the Glass platform, which is what it says on this slide. And I'm going to be going through kind of a lot of things we've learned along the way as we've built Glass, and we've developed the APIs for everybody else to be able to build software on Glass. Before I get into that stuff, let me tell you a little bit about myself, which will be shorter than normal. Never had an introduction before. So I have that really long title. I'm a developer programs engineer on Glass. And what that really means is I help people outside of Google build cool stuff using Google APIs and technologies. Specifically, I focus on Glass. So I help people write stuff that we call Glassware. That means that in practicality, that means I help design the API. I come talk at events like this. And I spend a lot of time pair programming with people just in the developer community. And if you'd ever like to reach me, an easy way to follow me is on Google+. You can find me there at google.com/+JennyMurphy. Let's dig into the meat of today's presentation, the menu. So how many of you have had an opportunity to see a demo of Glass? A few of you, but not very many. So I'm going to start off with the demo to give you some context, to show you why Glass is special, which is kind of the whole framing of the presentation. Once you've seen Glass in action, we're going to talk about the platform from the 10,000-foot view. An overview of kind of our strategy for the platform as a whole, and some philosophical design guidelines that we've come up with that we think apply to kind of wearable computing in general in both parts of the Glass platform. And then we're going to take a deeper dive into one part of the platform, the Mirror API. That's the part of the platform that's currently out there for development and use. So let's get into that demo. So I'm going to switch over to a different Glass that's plugged in right now with a cable, so you can see what I am seeing on Glass. And there are a couple caveats to the presentation software. So is it up there? Yeah. So most of the time, so a couple of caveats. The frame rate up there is a lot lower than the frame rate on Glass right here. It's just because it's copying frames individually down to show them to you. The other thing to note is that if you see black on the screen, it's actually transparent to me as a user of Glass. So Glass blends a lot more into the background. Okay. So most of the time when you're using Glass, this is pretty much what you see. You see whatever's in front of you, the world around you, and Glass isn't displaying anything. In a day of heavy use, I probably have the screen on for maybe 10 minutes. But let's bring it on. I can bring it on by tapping on the side or looking up. First thing I see is kind of the home screen. The time. Always useful to see the time. And a phrase underneath that. OK, Glass. This brings up a list of actions that I can do. Oops. OK, Glass, take a picture. One of the actions I can do. I took a picture of all of you fine people. I can do some other stuff too. A lot of things listed there. OK, Glass. Google, how do I say dinosaur in Swahili? Glass is doing a Google search, and it brings back a knowledge card. Oops, this one was not. I did not pick up Swahili. Let's try a different language. OK, Glass. Google, how do I say dinosaur in Japanese? Here, we get a knowledge card back for a lot of searches. And it actually read it to me in Japanese so that I can try and pronounce it. Let's try that again. Kyoru. I'm probably way off in pronunciation, but if I'm in a pinch, that could help a lot. So I can bring up knowledge cards. I can do actions like take pictures, record videos, get directions. And that's kind of one half of the overall usage flow of Glass. That's kind of asking for information and creating and kind of poking and triggering stuff to come back to me. Glass also is great for handling kind of passive stuff coming in. So while I'm out and about using Glass, I'll often hear a chime, which means that a notification has come in. I can ignore it, or I can nod up to see it delivered. And if we go back through the main interface, it's just kind of like a timeline of those notifications that have come in. I can see the past things I've done, taking some pictures. I can also see some notifications that were delivered earlier while I was setting up. Like field trip notification that I was walking by a landmark, Kenny Gym, an SMS conversation with a friend, stuff like that. There's also some stuff that's kind of ongoing or in the future, and that's on the other side of the clock, which I don't have any configured on this account right now. But that might be like weather forecasts, traffic, that kind of stuff. So that's kind of the basics of Glass. It's a lot of kind of micro bits of information that I can have short interactions with while I'm out and about living the rest of my life. We're actually here to talk about platform. So hopefully that gave you some context, because we're going to talk about how we build stuff for that platform, for Glass. And the Glass platform has a couple different components. The first is the Google Mirror API. This is the first part we came up with, and it kind of came about almost accidentally. We were building a lot of kind of the first pilot software for Glass. A lot of the stuff we knew had to be there, like Gmail, SMS, weather forecasts, calendar, Google Now, all that kind of stuff. And we noticed there was this common set of interactions, this common set of infrastructure we were using across all of them. That became the Google Mirror API. It abstracts away a lot of that kind of fundamental stuff. And that's also the API we launched first. There are a lot of people building on this API today. And then a few months back at Google I/O, we announced that there's another part of this. Whereas the Mirror API exists to make easy stuff easy, we know you also need the flexibility to do cool, powerful stuff. This is GDK, Glass Development Kit. And this is inspired by some of the other built-in features, like navigation. So let's look at them in a little more detail. Why would you use one versus the other? The Mirror API, as I mentioned, makes easy things easy. It's intended to make development really fast, and it's intended to allow you to create software that takes advantage of kind of those philosophical design guidelines we've learned, kind of without effort. It has a lot of built-in functionality. It's also language independent. It manifests as a bunch of web services that you interact with from another web server. And we use a language independent protocol called REST and HTTP to communicate that information. So if you like Ruby, Go, Java, Python, whatever you like, you can get up and running building a service with the Mirror API right away without having to pick up as many new technical skills. And it also makes a lot of use of common infrastructure. It uses a lot of software on Glass and on Google servers so that you don't have to write it yourself. This makes it, again, faster to write software, and it also allows us to do some optimizations and save things like power. Mirror API is very power efficient. And there's the flip side of that, the GDK. Because not everything you want to do on something like Glass is going to be the easy solution, the one we kind of like, the road that's already set out there. You may want to go off the beaten path. So GDK is actually code running on Glass. So if you need to do something that doesn't require an internet connection, because all Mirror Glassware is kind of synchronized over the internet with round trips, you'd want to use GDK. You can run the code when you're out and about at the Grand Canyon, away from cell reception. It's also real time. So if you need to take an action that needs to happen very fast, in like millisecond time range, GDK is going to be a lot more responsive. It also gives you direct access to a lot more of the hardware, specifically things like the sensors. The IMU, which is like the accelerometer, gyro, the compass, and direct access to the camera and that kind of stuff on Glass. So it allows you to kind of do much more expansive stuff, but it's going to take a little more work. So those are the two parts of the platform. We think they're both really important, and depending on what you're trying to write, one of those is, we think, going to be a really good fit. So let's talk about the design principles. Design principles, these are kind of like the philosophical underpinnings of kind of the guidance that guides us as we write our own software for Glass and as we design the API. And we pick these up just by using Glass for a long period of time and discovering the things that we thought would be really cool that turned out to be awful, and the things that were unexpectedly big impacts on our life. So I'm going to go through these. First one is design for Glass. Glass is a different platform. It's different than a lot of the technology we've used so far. So this is also kind of a common pitfall when making a transition from one platform to another. If you take something that worked great on like a laptop and you port it directly to a mobile device, it's going to be not a great experience. Same thing holds true for Glass, except to a much greater extent. The interaction is so different than a lot of other interfaces we've had before that you really have to make sure that you design for Glass. And the most important part of being able to do this is to actually try and use the software you write in your life, away from your desk while you're not coding. Here's an example. Here's CNN's tablet app. This is great. I pull out the tablet and I can catch up on news. I can sit back on a couch and scroll through stuff and really quickly glance around the screen, get up to date on a lot of news, click in and take a peek at some videos for other content that I find more interesting. This works great on a tablet, but if you tried to port this straight to Glass, it's going to be way too much information and it kind of thrown at the user at once. So collaborating really closely with CNN, we came up with a different design. It's a lot different than what you see on the tablet. It's much more focused on the content. There's one piece of content being displayed at any given time. And it's really easy to take a quick peek at and either click in to view the rest of the content or move on with your life. Next one, don't get in the way. So we expect you to be using Glass in places that are different than you may be using other computers in the rest of your life. So if, like for example, kind of a flip side on this, if I'm writing software for a mobile phone and I'm successful at that, the software is really engaging. The user is completely engaged and completely focused on the software. Everything else kind of fades away in the rest of their life. And that's also true of like laptops, desktops, a lot of software you're writing. If you're successful, you're going to suck up the user's attention. That's not the case with wearable computers. Someone's wearing a computer like Glass. They're wearing it in their life. They're out there. They're exploring. They're having adventures. In this case, we're at the Grand Canyon. Maybe we're going to go rappel down a cliff or something cool like that. If we end up getting sucked into the software and we have to do kind of continuous interactions, it's going to take us out of that moment. And that's kind of something we want to avoid. So for example, if I want to be able to grab a photo and quickly share it, I want to be able to do that without it being dependent on other actions. I want to just be able to do that with a small set of interactions and be able to move on and get back to my adventure. Next, keep it relevant. So this is both keeping it relevant, the kind of content you're displaying, both on a time scale as well as a location scale. So a good way to kind of think about this is like the time frame of information you look at when you interact with the system. So like we have data on the cloud. I have my photos on the cloud. I expect to be able to have many different ways to interact with my data on the cloud. And I expect that to have kind of like my full history, to be kind of permanent. If I upload a bunch of photos, I expect them to stay there pretty much forever. And it's kind of like my vault. If I'm using my laptop, most of the data I interact with is kind of on months to a year scale. If I haven't touched a project in a year, I'm probably going to delete the code and let the GitHub repo save it forever. If I'm doing planning, I'm probably going to do planning on the scale of months or a year. Just kind of at that kind of target. If I'm using a mobile device like a phone, I'm probably not going to try and plan out a year of meetings on my phone. But I might schedule meetings a month ahead, a month behind. Glass is kind of the same, on the same tangent, just like, but to a much greater extent. Glass is a much more focused interface. So it's very important that you focus on the content that's relevant to the user at that very moment and at the location they happen to be. For example, I was at this fabulous market, which I actually got off a stock photo site. I wasn't really here, but I was at a similar place buying some stuff for my trip out. And it was very easy for me to go and take a look at the list of information, my shopping list, off of Evernote. I had to get those healthy snacks, an umbrella, and of course the unhealthy energy drink so I can be full of energy for a conversation right now. And that information is relevant to me while I'm there shopping at that very moment. Now that I'm here already, it's not relevant to me now. It wasn't relevant to me 2 weeks ago when I wrote it. That's what we mean by keep it relevant. Next, avoid the unexpected. This is kind of a general philosophical principle that we've had for a long time at Google. You don't want to surprise the user. There are good surprises, but in general, software surprises tend not to be the good kind. So you want to be honest about the intention of your software. You want the user to know what to expect. Let me tell you a little story about how we tripped up ourselves earlier on in the project. When my team first started, we wrote our first batch of Glassware. It's like one of the first things we'll do when we land and we're working on an API. We'll use it, of course. We want to see if we encounter problems while we still have a clean slate. And one of my colleagues wrote an RSS reader. It was the first thing he wrote. And it was great. It was like, oh, I can get all this content onto Glass like right now. So I went out there and I grabbed news streams. I went out there and grabbed all my friends' blogs, a bunch of GitHub repo updates, a bunch of Stack Overflow tag RSS feeds, and just jammed them all in there. And then I left work, and I went out to go watch roller derby, one of my favorite hobbies. And something happened. Glass kind of went crazy. I was getting tons of notifications. Every 5-10 seconds, I was just getting slammed with notifications. And it kind of took me out of the moment. I had to turn Glass off, and it wasn't as useful then. What I mean by avoid the unexpected. With CNN, CNN has a great solution to this. They just made a simple configuration page where the user can specify like when they're going to be getting the data and what kind of data and how much to expect based on their other selections. And it's a really simple concept, just a configuration page to give the user an expectation of the amount of content they're going to be receiving. That was all it turned out that we needed. It was an easy solution. And now I know that I'll be getting, what is that, about 30 notifications a day? Sounds good. I like news. Next up, build for people. This one's a little bit more abstract, but it's really important for Glass. And I think a good way to frame it is there was an author and researcher, Jaron Lanier. He worked a lot on VR, virtual reality, when we were like in the early 90s when a lot of that research was going on. And one of the things he used as kind of a guiding principle behind a lot of stuff he built is a little bit sci-fi-ish. It's like, imagine a world in the distant future when humans are long gone, and aliens come back and they find all our stuff. What can they tell about us based on the artifacts they find of us? So if they find a carpenter's toolbox, they're going to be able to tell a lot about us. They'll find a hammer. They know a lot about the hammer's function. It has a handle. You hit things with it. It's pretty straightforward. Same with a saw and a lot of other tools you'll find in a toolbox. But if they found our computer, like a laptop, they'd be really confused. They'd be like, well, it's very clear that whoever used this had 104 fingers and one giant eye. Glass, we're hoping to take a big departure from that. So keep in mind that you want to really design for the people who are going to be using Glass, because it's a pretty intimate interface. Here we have them all on one slide. Those are our 5 philosophical principles. So while you're building for Glass or any wearable in general, try and keep this stuff in mind. You're not building on a smartphone or a tablet or a laptop. You're a lot closer to your user than you've ever been before. So respect that. The meat of the presentation. Let's talk about how the Mirror API works. So here's the really super complicated diagram of how the Mirror API works. It's got 3 boxes on it. These are all the little different components. We have all those Glass devices that are connected to your Glassware service. We have the Mirror API itself, which is kind of like a collection of RESTful web services. How many people here are familiar with REST? A lot of people. I like this is more and more every time I talk. It's like catching on or something. What REST really means is taking an API, an interface, and exposing it as a collection of web stuff. In this case, it's kind of like a bunch of directories of web pages, except instead of web pages for you to consume with a browser, it's a bunch of JSON for your software to consume. You can do things like a get operation, like loading a web page, except you're getting data for a specific user. You can do things like post, equivalent of a form submission. You can send data. And some other operations like delete and put and stuff like that. But it's all built on top of this exact same standards. Interacting over REST, you have your own Glassware, which from the Mirror API is typically going to be a collection of stuff running on a web server somewhere, although it can actually run anywhere that has an internet connection. You just need to be able to modify those collections. So even though we had 3 bubbles up there, you actually only need to think about one while you write. You only need to worry about your Glassware and the interaction over those collections to the Mirror API. All the other stuff is handled by Google already. So the Mirror API already exists. to what you're interacting with. And then in the background, you can kind of assume that all of that content that you're creating and manipulating is going to get synchronized to Glass. We handle all those low-level details. Paying attention, you may notice I kind of missed one important thing here. There's no access control. There's no guarantee. There's no authorization. Google doesn't know whose users you have access to right now, or what users' data you have access to right now. And we solve that with something called Oauth. Oauth is a protocol for doing kind of that three-way handshake, although I like to think of it more as a dance. And it's how we all agree, the users, you, the developer, and Google all agree about what data you have access to and what users have authorized that. So let's walk you through the dance. So our goal is to be able to hit that, access that JSON over HTTPS for a given user. But we need more. So if a user you don't recognize appears on your service, the first thing you're going to do is you're going to initiate the Oauth Flow by redirecting them to a Google server, and you're going to identify yourself in that redirect. That's going to bring up a dialog that asks the user to grant you a certain set of permissions, which you asked for. And of course, because you're only going to ask for a reasonable set of permissions, they're going to grant you those permissions. That's going to cause the web page to redirect back to your systems with a code that has been attached to the redirect. That code signifies that the user accepted the permissions. But there's one more step we have to do. Your server has to agree with Google and validate who you are as a server. So what you do is you take that code you got in the previous step and you do a background request, web server back to the same Google web servers with that code and then another token that identifies you, your client secret. And in exchange, Google will send you back an access token, which, whenever you make a request for one of those collections, you just add as a header. That access token contains all the information about the scopes that you've been granted access to, and it also encodes the identity of the user that has granted you that access. So you store one for each of the users, and then whenever you need to do an operation, you include it. Now we have all the pieces we need to start using it. So let's take a look at all the pieces that make up that API. There are 5 of them. There is the timeline, which represents those cards on Glass. They're the way you display content to the user. There are menu items, which are actually a component of the timeline, but I call them out separate because they're a little bit different. They allow the users to interact with those cards and for your Glassware to detect when those interactions have occurred. Next, we have contacts. Contacts are an abstraction for you being able, or for a user from Glass to be able to push information without a card to your Glassware. For example, sharing a picture or video, or perhaps using a voice menu. We also have locations. Users can grant you, the Glassware, access to where they're currently located, which is great for location-aware Glassware, like Field Trip, which we saw in my class. And finally, subscriptions, which are a non-functional, it's kind of like a utility collection. It doesn't actually provide you any new functionality. It just makes things a lot easier to do and allows you to write code that's a lot more efficient. So let's take a look at the timeline. Here's a timeline I might have typically on Glass. Some stuff in the past and the clock right there. A lot of those on my Glass usually. Let's take a look at what these actually appear to be from the API. Like I said, we like to make easy things easy. Hello World is not a whole lot longer than Hello World itself. You create a timeline item. You say, hey, there's text, Hello World, and then you send it over to the API. And this is what the user will see on Glass. You can also attach content directly to the card. In this case, is a picture of Chipotle, the best cat ever. And you do that just by making a multi-part request and attaching the binary content. You can attach photos and videos. Not everything is just pictures and text. Sometimes we like actual formatting. In this case, we might want to describe a movie about a very similar appearing but different cat, Manchego. So the movie about Manchego is represented on Glass in this case with an HTML card. covers most of the stuff, except cases where you're not really sure what the length of the content is. So there are going to be cases you run into where you can't predict how big the content is going to appear on Glass. This is really common for cases like user-generated content, comments, or just content of indeterminate length, like a recipe, for example. So we made a way for you to specify multiple page content or content that you would like us to automatically paginate for you. So it's just a couple properties we added to the HTML scheme, or I guess attributes technically. So we've seen the JSON. Let's take a look at the code that you might use to insert it. Like I said, this stuff is language independent, but I picked Java because it seems to be a popular language. And here's, if you do develop in a different language, especially if you use one of our client libraries, your code's going to look very similar, except more like whatever that language is. But in Java, if we wanted to insert hello world, we're going to take a service object, which is going to be yielded by that Oauth Flow, or we would create from a stored key. We're going to create an abstract object. In this case, it represents a timeline item, one of those cards. We're going to set our properties, and then we're going to insert it using the API. And we're going to respond to any errors that might be there. Super simple. Yep. And, but that's actually all, let me go back. That's actually all you will need to do for any of those other ones. You're just going to be setting other properties and doing the same insert. Next. Cards are great, but it's really cool if the user can interact with them. This is where menu items come in. Menu items exist as other properties on timeline items. So you have a timeline item, you just add some more properties that create menu items. There's a couple of different kinds of menu items. First class is these built-in menu items. Built-in menu items trigger functionality that's native to the device. So for example, share does something special. It kind of allows you to copy a card that's accessible from one Glassware and share it with another. The common case for this is I take a picture on Glass and I share it with another Glassware so they can do something cool with it. Get directions. We'll navigate to some location information you've embedded in the card. And reply will create a new card that's a child of a card that already exists that allows you to capture voice transcription. So when a user triggers reply, a prompt comes up for them to speak, and then your Glassware has access to the transcribed text. We have like 6 or 7 of those right now. I think actually 8 now. And they expose a lot of cool functionality, but we know that if you write your own Glassware, you're probably going to want to specify some that are specific to your use case and your software. So you can also specify a custom one. In this case, it's not going to trigger any like built-in functionality like the voice transcription service or the navigation. What it will do is it'll allow you to receive a ping back when the user toggles this. And then you can specify it and make it look however you want. Specify an icon, all that stuff. That's menu items. Next up is contacts. Contacts, as I mentioned, represent kind of like a context-free ping, which means they can represent all sorts of different stuff. They're a pretty broad abstraction. They might represent a user, for example. So for a social network Glassware, you might have a contact for each user. They might represent a group of people, in this case, a Google+ circle of my friends. But a lot of the time, they represent something a little bit more abstract. They represent something like the Glassware itself, the whole piece of software, or maybe a specific function of that piece of software. One of my many Tumblr blogs, for example. You can do a couple things with those contacts. One of the most basic cases is I can use it to share photos taken on Glass with that service to do cool stuff with it. In this case, Google+, sharing it with a circle, it's going to copy it to Google+ and share it with my friends. But there's all sorts of neat stuff you could do with that. Code to implement this looks a whole lot like manipulating a timeline item. There's just a little bit more abstract data. It's not all displayed here. There's a few fields there. There's a set ID field. And what the ID field does is that's kind of a marker that you set on a contact. And then when we send you a ping back later, that's how you tell which one of the contacts you gave us got triggered. So if you have like 10 contacts, that's how you distinguish them. In this case, Chipotle the cat. Some display fields, a display name, and an icon. Those are pretty obvious. And accept types. Not every piece of software is going to be able to handle every single kind of content. Maybe you only want to be able to receive text content or images. So if you want to narrow the kind of stuff you can receive that you're expected to be able to handle, you use accept types. And these are just MIME content types. And then just like anything else in the Mirror API, you would insert it. That content now appears on the user's glass, and they can send stuff to it. Wait, there's a little more. Context can also be used to represent voice commands. It's that OK Glass menu. So if you're writing software and you need to have kind of like context-free something to happen, like, for example, calling a car, or, yeah, we'll stick with calling a car. Then you can add a voice command menu item to it. And the way this will work is I add a voice command, in this case, a social network for cats that I called CatStream. What will happen is the OK Glass menu will come up. I'll ask to post an update, and it'll, assuming CatStream is the only Glassware I've installed that uses that, it'll bring this up and ask me to speak to CatStream, in which case it will allow me to post items to CatStream. This looks very similar to the contact code that we just had up. The only difference is instead of an accept type, we have an accept commands. An accept commands takes a string identifier, which represents one of the built-in menu items we have available for you to use in your Glassware. There's 2 right now, but we're looking to add a whole lot more. So if you have any ideas, let us know. I'd like to add more. That's context. It allows you to kind of get that context-free ping to your Glassware. Next, locations, which is super simple. Location of our Glassware is really powerful, but you need to know where your user is for it to make sense. So what locations allows you to do is allows your user to grant your Glassware the ability to see where they are. This is a separate scope because it's kind of personal information. And then your Glassware will get a ping back approximately every 10 minutes while their glass is on, telling you where they presently are. Once you have the scope, once you've done the OAuth dance, if you want to see where the user is, you just go and do a get on the locations collection, and you get their latest location. And latest is the only value available in that collection right now. Once you get their location, then you do cool stuff with it. In this case, we're printing it out, which isn't that cool. But I'm sure you can think of something better. Like field trip shows you nearby landmarks. All right, one more collection, subscriptions. So we now have all the pieces we need, all those Lego blocks we need, we can use to start to build those Mirror API Glassware. But it's very hard for your software to know when something has happened at this point. When a menu item has been triggered, when a contact has been triggered also, you can sit there and you can crawl those collections to see things that have changed in the state. But then you'll run out of quota really fast. It'll just eat up all sorts of resources in quota. That's where subscriptions come in. Subscriptions are also cool because they implement a protocol called pub/sub/hubbub, which is really fun to say. And the way it works is it's kind of backwards. So in the case, everything else we've talked about, you've been sending data through the Mirror API to Glass. In this case, it goes the other way. If something happens on Glass, and we send you a ping back to your Glassware so you can respond to that. This happens in a couple different phases. The first phase is you establish a subscription. So you tell the Mirror API what you're interested in listening to. You listen by collection. So you might listen to the timeline collection, in which case you're looking for those menu items being triggered. You're looking for new photo shares, stuff like that. When you insert it, you give us a couple tokens, a user token and a verified token. These are opaque tokens. You can send us anything you want, and we will send it back to you with each one of those pings. This is very important because most of the time you're going to have some kind of session information when your user interacts with your Glassware. But in this case, you won't have that session information because these pings are coming back from the Mirror API. So this is how you know what user has actually triggered that notification. And then we need a callback URL. This is where we send stuff, where we send those pings. And then just like everything else, you do an execute to insert. And then the subscription now exists, and you're going to start getting notifications back. Here's an example of a notification you might get back. In this case, we're listening to changes in the timeline. You're going to get back an item ID. The item ID is there so that you can go to do a get on the timeline collection to get the rest of the details about what happened. Because if you notice, this ping is really lightweight. because in practicality, you're actually going to throw a lot of these pings away. So we didn't bother populating most of the fields. We have operation and user actions. These give you more details on kind of the specifics of what triggered that ping to hopefully save you some GET requests. And then you have your user token and verify token, which were just sent back from when you insert the same values you inserted when you inserted the subscription. You're going to get something very similar for a voice command. The only difference is the user action has changed. So there's a bunch of different user actions that correspond to different kinds of things the user may have done. You can also get updates on a different collection, locations. So locations are a little bit simpler. There's only one item in the collection, so the ping reflects that. It doesn't have a lot of those things that tell you exactly what happened because there's not much that can happen right now. It just tells you that their location's been updated. In this case, Chipotle has moved, and you got a new ping about where Chipotle is located. Look at that JSON in code instead. So here's the first step. Oh, here actually processing a notification. Actually, the second step. Inserting a subscription is a lot like other kinds of inserts. Responding to a notification, though, is a little bit different than the code we've shown before. Because as I said, there's no session. So you have to figure out the user from the contents of the request. So pings are always going to come back as HTTP posts. Google is going to post data to your server. So however you would respond to that, you respond. First thing you're going to do is parse the JSON that comes through in the request body. In this case, we're going to parse it, and we're going to unmarshal it into a notification object. Next, we're going to look at the contents of that JSON. And in this case, we're going to verify that we have a user that we know exists, and that we can verify that that is authentic. Because anyone could actually send a ping to your notification URL if they find it out. This is how we know to make sure that it's coming from Google. Then, now that we know we have a valid, authentic notification, we're going to do stuff. So we're going to do, there's a lot, like typically here you're going to have some kind of branch logic where you start branching on those user actions and the collection and do different things for different kinds of notifications. That's all the collections. So let's bring them all together with an example. A great piece of software. It's called Add a Cat to That. And what it does is it makes photos better. Because photos are great, but photos with cats are so much better. And this uses a surprising number of features of the Mirror API. It's amazing the ways you can combine these different kind of Lego bricks. It's not location aware. We don't really care where you're adding cats to photos. But it actually uses pretty much everything else. It uses the timeline collection. It uses menu items, contacts, and subscriptions. So let's see how we actually build this and how it works. Here's a description of the flow. The flow for Add a Cat to That is broken up into a couple of different phases. The first phase is the Bootstrap phase. This happens when your user first signs up for Add a Cat to That. We're going to do that all at once. In step 1, we're going to store the resulting tokens on our server. And then we're going to do a couple Bootstrap things. We're going to insert the Add a Cat to That contact so that we can get those photos. And we're going to subscribe to updates of we're going to subscribe to notifications of updates of the timeline collections. So we know when a photo has been shared. Later, during runtime, users out and about at the Grand Canyon, they wish they had a cat in their photo. So after they take their photo, they share it. This causes a notification to get sent back to our Glassware. We identify that notification. It's bona fide. It's genuine. We want to do stuff to it. We're going to add a cat. So we fetch the photo. We add the cat. And then what we do is we update the item with the cat inserted. And then the Mirror API synchronizes that back to their Glass. That in code. It looks a lot like code we've seen in some previous slides. So we're inserting the contact during the Bootstrap phase. We only want to accept images because our technology is not quite advanced enough to handle videos yet. And then most of the other fields, like the ID, we're only inserting one contact, so it's not really relevant, but we might want to add it just to have future expansion. It's also a required field, so we have to put something there. And we need to set some display fields. The next part of the Bootstrap, we're going to subscribe to notifications. We're subscribing to notifications of the timeline collection. Now, our users out and about, they've shared that photo, we're on to that second phase, the runtime phase. Here we are handling a notification of a photo that needs to have a cat in it. We parse it, we verify it, we do our cool stuff once we've verified that it's a share. In this case, we're going to add a cat to that. We add a cat like this. We pass in the ID of the timeline item we're going to add a cat to. We're going to go and we're going to do a little defensive programming here, just in case somehow a timeline card has multiple photos on it, which can happen in the API, the way the API service is described. We're going to add it to all of them. But in practicality, almost every one of those timeline items you get will only have one photo to add a cat to. We're going to go step into another collection and get the bytes of the photo. And then we're going to process the photo to add the cat. Next, we delete the old photos on that timeline item and insert the new cat-enhanced bytes. Then we do something very important. We add a menu item to add a cat to that photo. This allows you to share it again. So you can share your cat-enhanced photo to a social network, for example, but it also enables one other powerful case. You can send that cat-enhanced photo back to add a cat to that to add more cats. So you could add 1 or 2, or like my favorite number, 7 cats. So in that little chunk of code, we end up using those 4 collections. So I haven't actually run this code in a long time. Let's see if it still works. Shall we? So let's go back through. I took this great photo of all of you. And I'm going to share that with add a cat to that. On up onto the internet. So there it created a new timeline item that represents that shared photo. And now it's synchronizing over the very fast internet connection through my cell phone. And we should get a notification in a couple moments that indicates that a cat has been added to the photo. Oh, it's been synchronized. So now the servers are chugging away, adding cats. Identifying the important cat to add, which in this case will be Lexi. Okay. How many cats? The add a cat to that only supports Lexi right now, only 1 cat. It was.
Once the full release comes out, the pro version.
The pro version may have more cats, or maybe even puppies. So it's quite possible that add a cat to that crashed. Aw. There was just too much awesome in that photo. But we'll see if it actually responds while we go on to the next step, the very important step of taking questions. So we went through some guidelines that we learned, many of them the hard way, while we were building Glass. And we went through one of the APIs that we developed in response to all that stuff we learned while we stubbed our toes and stumbled while working on Glass. So we hope that's useful for building for Glass or any other wearable computer. So now for questions, and hopefully add a cat to that will respond. Questions, anyone? There's a microphone going around, too.
So, wow. If you want to add a cat to a picture, what happens if you still want to keep the old picture? You said you delete it.
We're deleting the attachment, but there's one thing I didn't go into depth on the whole ACLing model. By default, your Glassware only has access to the timeline items that you created. Mm-hmm. So the way we resolve complexity of race conditions and stuff is whenever you share a timeline item between 2 Glassware, we copy it. So what happened in this case is you still had the original photo. We created a copy. And then that copy is what got manipulated by add a cat to that.
Okay.
So we don't destroy the original. That would be a bummer.
Can you add cats to already added cat photos?
Yes.
Excellent.
Yes, you can add as many cats as you want to photos. In this case, they'd all pile up because it's the same picture of Lexi.
So I noticed that all of those are done through voice commands. Have you thought of anything done by like eye movement or anything like that for people who really, really don't like voice commands?
So here's kind of one caveat for the Q&A. I can talk about what is. It's very hard for me to talk about what may be in the future, or like a lot of kind of the decisions we made in the past. But I can say is we experiment with a lot of different ways of interacting. Voice is cool because it's something that can be self-contained in Glass, and it's also very high bandwidth compared to a lot of other functions. So that's why like voice is the primary interface for a lot of stuff on Glass. So one down here, one back there. 2 microphones moving around. Wow, thank you.
You mentioned that it uses Oauth 2. Do you have to do the refresh token maintenance stuff, or is it simpler than that?
So for the Oauth 2 dance, yes, I oversimplified the Oauth dance a little bit. There's some other steps you do later, which is you refresh tokens. And the API itself, underlying, does not automate any of that, because that's just where the API stops. But we have client libraries and a bunch of popular languages. I think there's like 7 or 8 of them now. So if you're using a popular language, we've probably taken care of that for you in one of our client libraries. All the code I showed was using our Java client library. And in that case, you can kind of ignore all that other OAuth refresh stuff later.
Basically, if you added 2 cats or more to it, would it pick a different location, or would it just overlay another cat on top of the already added cat?
So the add a cat to that, adding multiple cats. We thought a little bit about building it, but I think we only spent, like to give an idea of how part of the Mir API design, I think we spent an hour writing that. So it doesn't do anything intelligent like that, but it could. It just, right now, there's actually 1 cat photo that it just recomposites over and over and over and over again. But it could be random, or it could know what it did historically.
How do you find that the transparency of Glass has affected your ability to clearly view pictures and video?
Pictures, can you clarify a little? Pictures, video on Glass, or?
Yeah, like if you want to look at your friend's photo stream, or if you want to watch like a YouTube video.
So how does Glass being transparent and a little bit translucent affect like consumption of content? I haven't really thought about that, which I guess is kind of shows like it kind of blends in. It ends up feeling a lot like a rearview mirror or like a TV across from the bar, neither of which are translucent. So I guess it hasn't really had a big impact on it. It's a pretty vivid display, and yeah, not as much as I'd think.
Hi, where did you get your skirt?
Where did I get my skirt? Adventure Time.
That is so awesome.
Thank you. I got my skirt off of Etsy. I can show it to you afterwards if you like.
Okay, yeah, thank you. I figured I'd be one of the only people in this room who would care, but...
I'm glad we all care about Adventure Time. That's really important. Yeah, that's important. That's the moral of this whole presentation, is that Adventure Time's awesome.
Hi. With the exchange of the security tokens between the Glass server side and the Glass locally, how do you prevent some, say, malicious people that would like to, advertise via Glass, maybe without the consent of Google?
So,
I guess, how do you keep people from making security tokens that end up like working with Glass without Mir API knowing what's going on?
how do we prevent users from like forging their own tokens?
How do you prevent like spam essentially from coming through the notifications? Or some company that's maliciously advertising using Glass.
So there are a few different mechanisms we use to prevent that. So we have some guidelines right now. One of the guidelines is no advertising on glass, which works well combined with the fact that we know the identity of people who are writing mere glassware because they sign up for an API console account, which gives them an identifier and some client secrets that are used in the OAuth events to identify them downstream. So we always know who they are whenever they make a request. There's also other mechanisms built in, like quota limits. So if someone tries to do something, if someone's system becomes compromised and something very suspicious happens, it's usually, like the quota is usually tuned to their typical behavior. So it's one of those things where it's like there's just many, many strategies that we use in general across all of our web APIs to prevent that kind of stuff from happening. A lot of it's baked into the Oauth protocol. Some of it is assumed security on the side of the owner of the glassware. And then there's some kind of fall-through ones that protect in cases where that stuff doesn't work out as well as we had hoped.
Hi, we've seen Evernote on Glass, CNN on Glass. Do you know, I'm just curious, do you know or any apps which are exclusively built for this platform or this?
Glassware that are exclusively built for Glass.
That probably couldn't be experienced in any other platform.
But they can't be experienced in any other platform. So yeah, I've seen a few things. Most of those things are still kind of at the hacker stage, which is really exciting. One example is someone I've hacked with at hackathons has started building a bunch of musical instruments that are side-loaded APKs for Glass. Because one of the cool things about Glass is that it's an Android device underneath. So GDK is not out yet, but you can start writing Android code and just side-loading it on. So she made like a trombone that you control the pitch with the touchpad and the amplitude with the light sensor. And she's also created some musical instruments that only really make sense in this kind of interface, that are a little bit harder to describe without demoing. And they're pretty cool. And I'm actually really hopeful that a lot of this stuff will start to kind of emerge as we get more used to building stuff we're kind of used to on Glass.
Okay, so you mentioned that your Google Glasses connects to your phone for internet. Can like an Android app, in theory, like interact with your Google Glasses? Like say, could an app maybe display something while it's running on your phone and then like work together for some purpose?
So using a phone is kind of like a tethered. So technically, yes. In practicality, it turns out to be complicated for some reasons. You end up with, when you do like, because it's an Android device like any other Android device. So you can always create an ad hoc network connection over Bluetooth or Wi-Fi. But you end up with challenges in terms of supporting that end-to-end relationship. It just ends up being a lot of testing. And also, in practicality, most of the time when you want to call out to a phone for some reason, for like backup processing or something, or more storage, it usually makes sense just to go straight to the cloud. Because why go to a phone for twice the processing power when I can go to the cloud for 1,000,000 times the processing power? And you know, a little more power versus attached to mains electricity at a data center. But there are some cases where I've seen people do novel stuff using a Bluetooth connection to the phone. That's also kind of in the hacker area right now, kind of active, ongoing hacking and research, which is pretty cool. So the short answer is yes, but